Hello students, my name is Dr. Swapnil Jain and I am working as an associate professor in Mechanical Engineering department at Kalinga University with 2 decades of enriching experience in teaching and research. My area of expertise and passion lie in manufacturing science, thermodynamics and strength of material. Through dedicated efforts, I have authored numerous research papers in reputed international journals, shedding light on innovative methodologies and discoveries in these domains. Additionally, my work has resulted in published patents showcasing the practical application and novel approaches in mechanical engineering. Within the university, I have been actively engaged in various research activities, fostering an environment of inquiry and exploration. Guiding projects at MTech and BTech levels has been gratifying experience. Today, I am honored to present a brief introduction to captivating area of manufacturing process. Manufacturing process form the backbone of virtually every industry, playing a pivotal role in transforming raw materials or component into finished goods. Their importance lies in their ability to enable efficient, cost-effective and high-quality production. These processes not only create product but also dictate their quality, functionality and affordability. They optimize resource utilization, enhance productivity and ensure consistency in output. Moreover, manufacturing processes can be highly specialized based on the industry and product requirement. Modern manufacturing often integrates advanced technologies like robotics, automation, computer-aided design, and computer-aided manufacturing system to streamline and optimize production. Manufacturing techniques vary widely depending on the product being manufactured, but they generally follow a series of steps. First, design and planning. After that, material selection, then pre-processing of the material, after that manufacturing techniques, additive manufacturing, assembling, quality control, packaging and shipping, and last, maintenance and continuous improvement. In this module, we especially address the surface aspect of manufacturing techniques. The subject manufacturing processes is segmented into 5 units and I will provide a brief overview of these units here. First unit comprises of conventional manufacturing processes. This unit explores fundamental techniques in manufacturing, focusing on casting and molding. It encompasses metal casting processes and equipment, emphasizing heat transfer, solidification, shrinkage, riser design, casting defects, and residual stress management. Heat transfer impacts solidification rates, microstructure and material properties. Shrinkage and riser design are critically in preventing defects, additional bulk and sheet metal forming, powder metallurgy principle, plastic deformation and yield criteria will be discussed. Unit 2 comprises metal cutting and joining processes. The study of metal cutting processes offers in-depth understanding of various critical aspects involved in shaping material. It encompasses an extensive exploration of single and multi-point cutting technologies, developing into the dynamic of force component and chip formation during the cutting operation. Understanding tool wear, surface finish, machinability plays a crucial role in ensuring the quality and precision of final product. Furthermore, this study involves a comprehensive analysis of cutting tool material, exploring their properties, suitability of the different applications, and the impact on machining outcomes. Flute and coating utilized in metal cutting process are examined, highlighting their roles in enhancing tool life and optimizing cutting performance. Additionally, student delves into machining techniques including additive manufacturing and CNC machining to comprehend advanced manufacturing technologies. Moreover, The curriculum covers the various joining and fastening processes such as welding, brazing, soldering, and adhesive bonding, offering a holistic view of method used to assemble and connect metal component, completing the understanding the metal cutting techniques. Unit 3 comprises grinding and super finishing. This section of study focuses on grinding process utilizing abrasive wheels, dissecting their wear mechanism, specialization dressing, turning and application of the surface and cylindrical grinding techniques. Additionally, it emphasizes the significance of super finishing methodologies like honing, lapping, and polishing, especially designed to attain remarkable surface quality and precision in manufacturing components. Understanding abrasive wheel operations, wear patterns, adjustment, and surface refinement techniques becomes pivotal in the pursuit of achieving superior quality and precision in metalworking processes. Mastery of these techniques not only ensure high quality finished product but also contributes significantly to overall efficiency and precision of manufacturing processes. Unit 4 comprises metal joining through welding. The module thoroughly explores the metal joining through welding, delving deeply into various welding techniques pivotal in industrial applications. Encompassing a wide spectrum, it covers gas welding, arc welding, TIG/MIG processes, resistance welding, and advanced methodologies such as atomic hydrogen welding, submerged arc welding, and friction welding. Furthermore, the discourse extends to include soldering, brazing, adhesive bonding techniques vital for diverse assembly needs. An essential focus lies on understanding the phenomena of weld decay in heat-affected zones, shedding lights on the alteration occurring in the metal's microstructure due to heat exposure during the welding processes. Proficiency in these diverse joining methods is critical for engineers, enabling them to select and apply the most suitable techniques for specific material and applications, ensuring strong, durable, and efficient assemblies in various industrial settings. Unit 5 comprises unconventional machining processes. This unit delves into a range of unconventional machining methods like AGM, WGM, USM, EDM, ECM, and electron beam machining. Students gain insight into the principle, parameter, and application of each techniques, emphasizing their pivotal role in the material shaping and removal. Factors like particle size, velocity, and precise process control are highlighted, showcasing the significance of these methods in shaping material by removing precious amount of material through controlled processes. Understanding these unconventional techniques equips students with diverse options for precious material shaping, essential in various manufacturing applications. This extensive study thoroughly covers both conventional and unconventional manufacturing processes, explains their principles, applications, process parameters, and crucial consideration necessary for precious and efficient production in diverse industries. Proficiency in these techniques facilitate the creation of high quality product, ensuring exact dimensional accuracy and achieving desired surface finish to meet industry standard efficiently. The upcoming module will explore into the comprehensive discussion on conventional manufacturing processes, focusing especially on the metal cutting and the joining processes. Thank you.